All right, next conic we're going to take a look at is what we call an ellipse. What an ellipse is, it's a set of all the points in a plane where the sum of the distances from two fixed points, which we call foci, is constant. So what they're talking about, this point right here inside this ellipse is what we call a focus point, as is that one right there. Okay, and if we pick any 2 points on this ellipse, okay, so this red one for instance, and I measure the distance, okay, and I take another point, the blue one, measure the distance from the 2 points to them. When I add those 2 segments together, those lengths, they will be the same. That'll happen on any point on the ellipse. So if I picked another one out here, okay, and measured the distance from it to my focus point and to the other focus point, that sum of those 2 segments lengths would be the same as the other ones. All right, some other points that we have is we have the center of my ellipse, okay, and that's going to be on a segment that we're going to talk about here in a second, where the 2 segments are going to intersect. So those segments, we have 2 of them. One's called the major axis. Okay, my major axis is going to be the longer of the 2. In every situation, it can be vertical, it could be horizontal. Okay, but our major axis is going to be the longer of the 2. My minor axis is the shorter of the 2. Okay, but where those intersect, that's going to be where my center is. Okay, and at the edge of those segments where they intersect my ellipse, those are what we call vertices. Okay, so what we're going to have are 4 vertices with each ellipse. And so we'll get these all set up. So I have a vertex there, I have a vertex there, down here, and over here. Okay, now when we're talking about these 2 things here, semi-major axis, that's half your major axis. Just like if we talked about a semicircle being half, so this would be the semi-major right here, this chunk here, or you could talk about this chunk over here being your semi-major. Either way, it's a half of your major axis. Just like with a minor, semi-minor, it's going to be half as well. Okay, so those are some of the parts you need to understand. We're going to take an equation and manipulate it here down the road and then be able to graph an ellipse from the information that we have. Okay, so when we talk about that, what we have is this is our standard form. Okay, so you should look a little bit familiar. The x minus h, that quantity squared, the y minus k quantity squared, that's just like we had in circle. This time the difference is we have denominators. And one of the new things that's going to happen with an ellipse and eventually a hyperbola is that they're always going to be equal to 1. Okay, so parts that we need to know. H, K is my center. Okay, HK is going to be my center, just like it was with a circle. And again, remember the idea of how you're just doing opposite when you're going from equation to coordinate and vice versa. All right. Now, some books will deal with A and B a little differently. They'll move those around from one fraction to the other. I leave them this way all the time, and I talk about A as being the distance from my center to my vertex in the x direction. And I tie that together because it's with the x. Same way, the B is your distance from your center to your vertex in the y direction, so up and down. Okay. I like to do it that way because then you have that association. Now, whichever one is longer then becomes your major axis. Okay, because like I said, your major axis could be going vertically, could be going horizontal. Okay, so that's how we're going to decide. Now notice it's A and B, not A squared and B squared, so what we're going to have to do is take the square root of those denominators. All right, so if I'm asked to graph this equation, x minus 5 all squared all over 4 plus y plus 2 all squared all over 9 equal to 1. We'll talk about how we know that's an ellipse here in a little bit. Okay, but what I'm going to start with is just like with the circle, I'm going to start with my center. Okay, so again, my center, the x, the opposite of it is 5. My y, the opposite, is -2. So I'll go over here to 5, -2, and it doesn't hurt to mark that that's the center. Second thing I'm going to go after is my vertices. Okay? And my vertices, again, that comes from looking at those denominator pieces. What I want to do, again, is take the square root of that denominator. That's telling me I need to go 2 in the x direction. So I'm talking 2 to the right and 2 to the left. Okay? 2 to the right and 2 to the left. So when I go 2 to the right, that's changing my x value to 7. When I go 2 to the left, it's changing my x value. Okay? But my y values are going to stay the same. We want to list these as points. If I do the same thing with the 9, take the square root, okay, get 3. Because that's the y, that's going to take me 3 up and 3 down. Okay. So now when we go up and down, my x is going to stay the same, but it's my y's that change. So from my -2, I'm going to go up 3 or add 3, and then I'm going to go down 3 or subtract 3. Okay, so there's my 4 vertices. Okay, at this point, yeah, I could probably draw my ellipse and be done, but we want to find all those other pieces that we were talking about. Okay. All right, so what we want to look at then is the length of this one. Notice we went 2 right, 2 left, so I'm doubling it. It's 4. The length of this one, I went 3 up, 3 down is 6. So that means the major axis is 6 units long, because that's the longer, and the minor axis is 4 units long. So if I sketch that in, and now I could actually sketch my ellipse. Okay. But if I go back and look here, now the only piece that I'm missing from this first page is I still need to find my focus points. Okay. Now, focus points are always going to be on your major axis. Okay. And the process of what we do, okay, is I'm going to take my big denominator minus my small denominator and take the square root of it. That's going to be my focal distance. That's going to be how far I go from my vertex on my major axis, or not from my vertex, from my center on the major axis to find my focus point. So in this case, I'm going to take 9 minus 4 and get the square root of 5. Okay. Now, square root of 5, it's a little more than 2, so there's one of my focus points, and there's my other focus point. And we're graphed. Okay, so all those things need to be found. Now, the last thing we want to do is not just graph them, is identify where they are. So because I moved up and down, just like over here, I moved up and down with the green ones, with the y's. My x's didn't change, but what I did was I took my y coordinate, -2, added the square root of 5, and then I took the -2 and subtracted the square root of 5. Okay. So what you would be expected to find when we do all this is center, vertices, length of the major, length of the minor, where are my focus points, and the sketch. All right, so now we'll look at general form. And just like we had with the circle, it looks very similar. You got ax squared plus cy squared plus dx plus ey plus f. Okay. How I know that we have an ellipse, okay, is again we're going to look at A and C, and they're going to have the same sign. Okay. I want them both to be positive. Okay, so if they are both negative, what I can always do is multiply by negative to get to that point. So my process here, very similar to what we did earlier. Number one, get my x stuff together. Get my y stuff together. and the constant on the opposite side. So we bring this over. What I now have is 4x squared minus 40x plus 9y squared plus 36y. Okay. Next, what I need to do is make it so it's 1x squared and 1y squared. So I need to factor out of these pieces. So I need to factor just out of the x pieces. Okay, so I look for a common factor between the 4 and the 40, which we're going to see here in a second is 4. I need to look at my y pieces and find a common piece there as well, okay, which is 9. Okay. And so when I do that, where I'm sitting is I took the 4 out of the 4x squared, the 4 out of the 40, so now in the parentheses is x squared minus 10x. Did the same thing with the y's. Okay. Because again, we're talking about completing the square. So that's my next step, is to complete the square in the parentheses for each set of parentheses. Okay, and if you remember that, again, what we're doing is taking half of this, so 5, and then squaring it. And I'm going to add 25. Okay, in here I'm going to take half of 4 and get 2, square it, and it becomes 4. Now what you got to be careful of is I'm not just adding 25, I'm adding 4 times 25 here. So I'm actually adding 100, so I have to add 100 to the other side as well. I'm actually adding 36 there. Okay, so that's one place where you got to be careful, because sometimes we forget that we're not just, or that we're adding more than just that piece that's half the linear piece squared. Okay. So we're there, and now we want our binomials again like we did before. Our perfect binomials should be available. And again, if you remember, that half of the 10 became that piece, the half of the 4 became that piece. Okay, now, one of the things that should be able to happen now is I want to make my constant 1. Okay, and the way we're going to do that is I'm going to come in here and divide this by 36. But again, if I divide over there by 36, I got to divide everything by 36. Now, the ones you're going to see, in general, you should always be running into these pieces out in front that we factored out being divisible or being a factor of the number you're dividing by. If not, you might want to double check your work. Okay, so when we do that, we now have it in standard form. All right, I'm going to kind of quickly graph this here. I'm going to put some things on here and then draw them in and then go from there. So the first thing I'm going to ask you to do is think about where is your center, then where are your 4 vertices, okay, and then the length of your major and minor axes. So I'm going to have you pause it here because I'm going to do the work myself, and then you can do it on scratch paper or whatnot. All right, so our center should be at 5, -2. Again, very similar to the earlier example. The only thing that really changed was our denominators. But I took the square root here, okay, and that's when I changed my y values. Added, subtracted, or x's, I'm sorry. Added or subtracted 3 to each of my x's. Okay, so that would give me these 2 vertices down here. Okay. And then what I did was took the square root of 4 again, added or subtracted 2 to my y values, gave me those. So then we talk about which one's longer. Well, the 3 times 2 is 6, that's why it's major. 2 times 2 is 4, that's why it's my minor. All right, next, pause it, find your focus points. All right, so again, what we want to do is take my big denominator minus my small denominator, square root. Again, it's that square root of 5. But this time, because my x is where my major axis is coming from, the x direction, that's why I added the square root of 5 to both sides there. All right, good luck with this.